The next panel session is on obviously compute, memory storage, FPGA, high density, and GPUs. And with me today, instead of having 5 panelists like Mark had, I have 2 panelists, Nehal and Greg. And Greg, would you go ahead and introduce yourself quickly? Tell us a little bit about the company and how long you've been in the space.
Yeah, so I'm Greg Jones. I'm part of the XR team at NVIDIA, and I manage a product called Cloud XR, which is our streaming XR architecture. I've been with NVIDIA 2.5 years or so. So really far up the stack, right? I'm really in the edge compute piece. Before NVIDIA, I was with a major university research group, led a couple 100-person research group in visualization techniques at the University of Utah, so academics to industry, and we've been working on XR, or interaction with your data is a better way to think of it, immersive interaction, for a number of years.
So from an XR standpoint, give us just sort of a little history of how we've gotten to where we are now, because maybe not everybody here is familiar with XR and that terminology.
You bet. So I'll XR combines 3 things really: virtual reality, augmented reality, and mixed reality, kind of captioned into that XR, extended realities type of label. So going back, just a couple generations of GPU, that's how I count time now that I'm with NVIDIA, is GPU generations, right? So it's only been a few generations where VR was really ready for prime time or really usable. So it's been an amazing climb from let's say the Maxwell generation to where we're at now, Turing, in the NVIDIA lineup, and really VR is now starting to see really nice organic growth. XR is seeing nice organic growth, and especially enterprise. But one of the critical features of delivering that XR signal to a user is your motion to photon, right? The time you turn your head in a headset or you move your device to see a new view, if you're in a headset, you need to have that motion to photon. The new pixels show up in about 20 milliseconds. If you go beyond 20 milliseconds, it confuses your vestibular system and you get sick, basically. There's some theories out there that the body thinks it's been poisoned, right? So it's time to empty the stomach because your motion and your vision don't keep up with one another. So that 20 milliseconds, and when you start thinking of the new platforms, 5G and such, and we're gonna see across large data centers across the network, we're gonna see 5 millisecond, 10 millisecond ping times. We're now in the vicinity where between the rendering speeds we have, between some of the ways we can kind of mask latencies, you give us 10 milliseconds and we can put a pretty nice VR experience on a remote user without using a tether to a massive GPU, right? So that, for us, that's one of the pieces that's going to be really interesting.
And it's interesting that you mentioned the visual effects, because with my work mostly in audio, delay and noise people, as you say, even with entertainment parks where they'd have visual rides, they would tell people, be careful, this may cause nausea, etc. So you're saying 20 milliseconds is sort of that threshold as to where that kind of thing begins to occur.
That's right. So 20 milliseconds, and you have to update the scenes quite often, right? So there's a 20 millisecond motion to photon, and then there's also the Oculus Quest, which is one of the leading headsets, is 75 hertz, and that's probably the minimum you can get away with your refresh rates on the displays for the goggles, right, for the VR headsets. What we're seeing is most are shooting for 90 hertz, and a couple out there are in the 120 hertz. So it's a really high performance workload with the 20 millisecond turnaround and the 120 hertz frame rates and 2Ki displays, which will undoubtedly go up in resolution. So you can imagine just the work it takes to get that visual into that system.
Got it. All right, Nehal, we're going to switch gears here. Introduce yourself. Tell us a little bit about your company and how long you've been in the space.
My name is Nehal Mehta, and I've been with Intel for almost 19 years. I manage the content delivery segment for Intel and also some of the Visual Cloud Edge initiatives.
Nice. And from a streaming standpoint, both streaming and CDNs, what are some of the trends that you've sort of seen in the industry or seeing going forward?
Well, so there is a lot that has been happening. Of lately, I would say that the technology behind content distribution and delivery has been evolving more rapidly. More than a year ago, we saw some early signs from some of our market leaders that the industry was getting ready to transition to 100 gig. And that pretty much drove a shift from what used to be spinning drives to NVMe SSDs so that you can now saturate all of the available pipe. One of the other trends that we are seeing is the rise in encrypted video content too. So it appears that the video content is following the same trend as the web content. So encryption is on the rise. And overall, we are seeing that the edge nodes are becoming more and more powerful. The focus from the content provider side is that they want to reduce the backhaul going back into the mid tiers, and they're looking at whatever technology is available, such as peer-to-peer technology, where you don't have to go back all the way to the mid tiers to fetch the content.
Greg, what about you? What are some of the sort of trends that you're seeing before we get into some of the more detailed questions?
Yeah. So I think, the interesting trends are, the thought right now, this very second, people are just saying, how can I get a video frame down quickly and within a certain lag time and such. But really where we're heading with augmented reality is we're going to build contextual representations of that image that we're pushing down. So we're going to take your real world layer context on that. Some of it will be video, some will be audio, some will be just text, right? But the deep learning and inference that contextualization will take means instead of just thinking of streaming video, we're really going to be working back and forth across the edge network to contextualize scenes for people. So there's going to be a lot of, can I do inference on the headset or on the hand phone or on the handset? Do I need to do inference at the edge? What data do I need to get to the edge? So what's the backhaul? How much video do I need to push to the backhaul to analyze those images? So we're going to see, the future trend is disaggregated compute. Where do I put different compute workloads between user device, edge, and then further back into the network with heavier compute?
So one thing we talked about sort of at the top of the sessions in the chairman section was the greening of streaming. Dom Robinson and I wrote an article that came out just a couple days ago looking at sort of power consumption. I know one sort of scenario that most people think about is GPUs, for instance, being power hungry. But in reality, it seems like it's the same amount of power for quite a bit more compute than we saw several generations ago. I mean, you mentioned some of the early ones, Kepler I worked with, et cetera.
Yep.
What are some of the sort of power concerns as you look at this distributed compute and as you look at GPUs specifically?
Well, yeah, it's an interesting question. So, of course, as we think about telco and these CDNs that'll run on the telco edge, you start getting into NEBS compliance and those types of issues. So now your power, your operating environment, all start making a really interesting package that you have to pay attention to. So certainly we've seen die sizes go down, or not die sizes, but transistor sizes and such go down. That helps with the power consumption. But it's really gonna, the workload that sits at the edge in those small data centers that don't necessarily have the best environments, those will have to be, the workloads will be really valuable there. They'll have to be very highly tuned for, a footprint that has to be well managed. There's not a lot of space in those racks. There's not a lot of cooling in those racks, and you're going to have to be performant even in really dire conditions, right? So you can take your GPU, it can do a heavy workload, but if something goes wrong, it has to throttle down and still be able to deliver telco services, right? So this power environment ratio that you'll see in the edge compute nodes, whether they're on a cell tower or in a small data center, fibered into different towers, it's going to be a really interesting ratio of power and cooling and electricity for that matter. So I think it's a brand new world, and we'll see different configurations come up over the next 10 years to really address that density that will have to show up in those data centers.
And it's probably, when you mention NEBs, it's probably not even just the cell towers and data centers, it's the slicks. Because if you're moving edge compute out into the traditional telephony space, even, or at the CO, where, as you say, cooling is not, the cooling standards in those models were not what they are in a data center, per se.
Right. Right.
Nehal,
So I think we'll really be, if a workload doesn't need 5 to 10 milliseconds, it won't get it, right? It'll be pushed back to a more robust system. Yeah.
correct. Nehal, what about you from a power consumption standpoint, as we're looking at general purpose processing, GPUs, even FPGAs?
Yeah, to me, I think edge is all about density. So not one solution is going to fit all. Different customers have different kind of requirements. So based on their TDP envelopes, based on the kind of workload they are running, I think overall there's just so many emerging use cases in edge computing that it's hard to say that one solution will fit everything. So that's where we kind of offer a portfolio of offerings to our service providers, and we work very closely with them to identify what would be best suited for their needs.
And what, mentioning FPGAs, what are some of the fits for FPGA? I know you and I have talked a little bit about this beforehand, and we had a panelist who wasn't able to show up in the FPGA space, but where do you see the fit on FPGA?
Yeah, FPGAs are a great solution. They can be used to help offload the CPUs. In short term, we have seen that there have been lots of security-related use cases around deep packet inspection, or even with TLS encryption. So those are great kind of features to offload from the CPU. And when you're talking about 100,000, 200,000 connections, it's lots of overhead on the CPU. Trying to terminate all the TLS sessions. The other area where FPGA could be a great fit is for media analytics. So, there are use cases around dynamic ad insertion. How can I monetize my content? So those are all great candidates for FPGA. There's also talks about, can we shift the transcode on the FPGAs for the edge? Traditionally for CDN, the transcode has been a function that has been limited to either origin or point of ingestion. But as Greg talked about, some of the emerging use cases like XR, AR, VR, immersive, I think there'll be a need for live transcode, which probably might be a great fit for FPGAs again.
And I think some of the work that I've been doing with the combination of ARM and FPGA for uncompressed video, to Greg's point on power consumption, we're having to pack these into devices that have no fans. And so when you start thinking about heat dissipation for a die size that's that large, it's pretty significant. Greg, so we're in the middle of a pandemic. It obviously has changed a significant amount about the way that we do business and even how we're doing meetings like this. But what's your sense in where GPUs play from a CDN standpoint in the post-pandemic world, or even in the pandemic world as we stand now?
Yeah, it's a great question. We're seeing a lot of interesting trends now, right? So the work from home, which is the kind of the lowest bar, is people are, as we don't get to go to our offices and get to our desktops, you're seeing more powerful laptops go out to the space. But even beyond that, we're going to want to get to our shared data sets, our secure shared data sets, and we're going to want to collaborate. So I think we're going to see a lot of maybe not edge, but a few milliseconds back behind the edge. I think we'll see a more and more of large engineering functions being done in the cloud and streaming on virtualization, virtualized system using virtual GPUs and such. I think that will be a trend that stays a trend, that stays a new way of working. And one of the things we've seen in the VR is really early, but the fact you can collaborate around a large digital model at scale is a really compelling piece of VR. And right now, if you want to collaborate, you have to be a robot avatar or you have to be a cartoon avatar. So there's a little realism that's dropped in the avatar business. But as we see those avatars get better and those virtual work environments get even better, the pandemic will hopefully fade away, and the need to collaborate across the world without getting on a plane will come up and replace the driver. But I think the trend that the driver is driving is going to stay, just because it's so valuable to collaborate, not have to take 2 days to get somewhere or a day to fly somewhere and live in a hotel for a couple weeks to work with the team. It'll be just jump into your system, put your headset on or however projectors, whatever you have, and that collaboration will actually drive this trend on a continuing wave.
So do we reach a model if we've got multi-tenant units, apartment buildings? I recently got married, moved out of an apartment to a single family home, but I could see MTUs actually having edge compute. And again, it may go back to something like a SLIC, but it may also go into the cable television servicing electrical.
Yeah.
Do we see those kinds of models coming into play?
Yeah, I think absolutely. And it's really interesting to watch the collaboration between like the telco providers and the CSPs right now, trying to figure that out, right? So Amazon Outpost for enterprise, Amazon Wavelength for the more public. So Amazon's working, I think, with Verizon, and they're saying, what does the edge look like? Where do we put the compute? And I think what you'll see is, if you have a density of humans, you'll see a density of compute going out to that edge. And it's going to be really fascinating when you think of how do you get the electricity in and energy out when you're running these big compute loads in older buildings, for instance.
Yeah, very, very true. Nehal, what about your take on sort of the pandemic world or the post-pandemic world from an Intel standpoint?
Well, so one thing for sure is that the appetite for content consumption has reached a new level, and we all are consuming more and more. So we have heard from some content providers that just on mixed content, the traffic has gone up by 30%. For what kind of use cases, VOD, traffic has gone up to nearly 50%. So I think we're getting more and more used to consuming more and more. And for many employers and employee, they have discovered that if they can be as effective working remotely, then that is all that matters. So one thing is for sure, the trend is not going to reverse anytime soon. And I think this will only put more and more pressure on the CDN providers to do more with less.
Very good. So before I ask sort of the last question here, I'm going to ask the audience, if anybody has a question, they can raise their hand. And if I believe what Dom has said is raise your hand and turn your video on. That way we can spot you quickly. So the last question for the panelists before we open it up to the floor is, when we're looking at CDNs, we typically look at things like, significant caching, but now we've got models like this where we're doing very low latency, limited ability to cache and that kind of thing. How do we see the space around video conferencing, web conferencing playing out in the CDN space, especially in this model where we're looking at a lot more work from home? And I'll open that up to either one of you to start.
Yeah,
sure,
I'll say, go ahead. Go ahead.
Greg. Let's do.
Oh, I was going to say, we've seen just in our company, but also in a number of groups, people we all are on Zoom or WebEx or Teams all day long, and it seems like the meetings have only increased with the work from home.
Very true.
Which is shocking. I don't get my plane time to catch up on email anymore,
sleep,
or sleep. But what we've seen are people want to have more meaningful interactions, right? So we've seen a lot of experimentation with VR. So the workloads just will increase to go up. And if you can do VR well, the limit of the avatars and how smooth and lifelike the interactions are still limited. But I think there's a lot of small companies, a couple larger companies working on those types of issues. So I think we'll see, richer and richer meeting experiences coming about.
So, Tim, I'm just going to chip in here. I think we have a question from actually one of our other panelists.
Real quick, though, Dom.
Yep.
Dom, hang on a second. Nehal didn't get a chance to.
Oh, I'm sorry, Nehal.
Oh, no worries.
Pause
No.
there.
Yeah, so Tim, my thoughts are very similar to Greg. I think there's definitely a need for more interactive and more immersive kind of experience, especially in this environment. And with CDN being all about locations, right? I think it has a great role to play for peer-to-peer kind of technology.
That's a very good point. Peer-to-peer is something certainly that would benefit in some of these models. All right, Dom, go ahead.
Yeah, I think we have one of our other panelists has actually got a question here. So I'm just trying to check that he wants to unmute and turn his camera on. But Mark Myslinski, are you out there? Possibly buried under some other windows. Well, usefully, I have a question for you guys, actually. I'm not quite sure whether it's my own ignorance more than anything, but I'm not quite sure how Moore's law has been affecting the GPU space and so on. But it strikes me that in the codec space, we're seeing sort of diminishing returns. The investment of, maybe 2, 3, 4 years on AV1 and so on is not exactly decimating the bandwidth that we are requiring on the network traffic. And so I just wondered in the GPU space in particular, whether we're seeing a leveling out in how far we're going to get by further with video compression for streaming versus quality. I wondered if you guys had any thoughts about whether we're going to see any significant jumps in the ability for GPUs to do low power, high compression, or whether we're starting to see something of a logarithmic tail.
And there's actually a chart that our CEO shows showing the kind of flattening of Moore's and the still increasing compute capabilities of the GPU. So we see quite a future still in performance gains on GPU computing. So I think Moore's law is kind of transferring from, I won't say from the GPU from the CPU to the GPU, but we've still got a lot of headroom on the GPU for gaining compute increases relative to Moore's law.
And I think Mark's now emerged. Mark, are you there?
Yes.
Brilliant. Did you have a question?
No.
Oh, that's confusing.
Sorry.
Make one up on the spot. No, I won't do that because you're on the panel next and we're also slightly overrunning. So I'm going to ask Tim to bring your panel to a close, if that's all right.
Sure. Yeah, I just had one quick follow-up, Greg, to what you were saying about the GPU compute. With XR, obviously, what we're dealing with there is multiple video streams potentially having to be encoded if someone's turning around, say 180 degrees to see what's supposed to be going on behind them from an immersive standpoint. Is that actually causing significant issues in terms of additional compute requirements?
Yeah. So I think we've had cards that we've built for the transcode market specifically with quite a bit of encoder capability in it, and our normal GPUs don't have quite as much encode, right? They've got encode for what they do, and what we're finding is if I can put 2 VR users on a GPU, which is really significant, since just 3 GPUs ago we couldn't even do VR. Now I'm talking about 2 heavy workloads. What I start bottlenecking at is my encoding function. So as these big graphics workloads come and they start going remote, balancing that encode to GPU compute is going to be some of the tasks that at least the XR team is asking our architects to look at.
Interesting. Nehal, any final comments here before we wrap up?
No, Tim. Not really anything specific.
Okay. Well, thank you very much for both of you for being panelists, and we look forward to if anybody would like to ask questions, they can do so through the Zoom chat directly to Nehal, directly to Greg, or you can put those questions out to everyone and then hopefully get a response back from the panelists. And Dom, with that, I'm going to turn it back over to you.
Awesome. Thank you very much, Tim, Nehal, and Greg. That was an awesome session. I really appreciated.